There is a river in the sky. It is an immense invisible torrent wider than 100 worlds flowing silently through the vacuum of interplanetary space. This celestial current is not made of water but of dust and ice, the spectral remnants of a ghost that haunts our solar system. For most of the year, Earth sails blithely above or below this stream, unaware of the cosmic debris field it navigates. But once every year, in the deep chill of mid-November, our planet's orbit plunges us directly through its heart, and when it does, the heavens catch fire. These are the Leonids, and tonight they return. This year, the celestial display promises a gentle but steady cadence, a predicted rate of around 15 incandescent streaks per hour. It is not a storm, not a tempest of biblical proportions, but rather a quiet, profound spectacle for those patient enough to watch. A cosmic whisper instead of a roar. Yet to truly appreciate this annual visitation, we must journey back not just in space to the origin of this dust, but deep into time to an age when the sky was both a god and a terror. For millennia, humanity gazed upwards with a mixture of reverence and fear. The stars were fixed eternal, a clockwork of divine precision. The planets, the wanderers, moved with a stately, predictable grace. But occasionally, without warning, the firmament would tear open. A star would fall, a fiery slash against the velvet darkness, a fleeting moment of cosmic rebellion. These ephemeral darts were seen as omens, divine messages, the fiery tears of forgotten gods, or the talons of celestial dragons. They were portents of war, the death of kings, the birth of empires. Ancient Chinese astronomers, meticulous record keepers of the heavens, noted these guest stars and sweeping stars with anxious precision, their chronicles filled with descriptions of sudden, brilliant apparitions, but no one understood what they truly were. They were a mystery as profound as the darkness from which they emerged. This ancient perception of celestial chaos was shattered on a single, unforgettable night in November of 1833. All across the eastern seaboard of North America, from Halifax to Jamaica, people awoke to a sky that seemed to be ending. It was not a shower, it was a deluge, a blizzard of light. Witnesses claimed the sky was so full of falling stars that one could not possibly count them. Estimates later calculated with sober scientific hindsight suggest a rate of over 100,000 meteors per hour, 100,000 incandescent visitors every 60 minutes. The heavens were alive, swarming with relentless silent fire. Imagine the scene, a world lit only by moonlight, candlelight and hearth fire. There is no electric glow to wash out the stars, no city haze. The night sky is a familiar, comforting blanket of infinite depth. Suddenly, that blanket is shredded by a ceaseless cascade of light. From a single point in the sky within the constellation of the Lion, luminous streaks erupted like a fountain of sparks arcing across the entire dome of the sky. Some were faint whispers of light, others were brilliant fireballs that cast fleeting shadows on the ground, exploding in silent, vivid bursts. The spectacle was so intense, so overwhelming, that many believed the final judgment, the prophesied end of days, had arrived. People fell to their knees in prayer, families huddled together in terror, awaiting the final cataclysmic trumpet call. But the world did not end. As dawn approached, the celestial fireworks faded, extinguished by the rising sun, leaving behind a profound question. What had they just witnessed? For a young professor at Yale University named Denison Olmsted, the event was not an apocalypse but an epiphany. As reports flooded in from across the continent, he noticed a crucial pattern. No matter where the observer was located, in Boston or Savannah or Ohio, all the streaks of light appeared to radiate from the very same point, a fixed location amongst the stars within the sickle-shaped mane of Leo the Lion. This was a monumental insight. If the phenomenon were atmospheric, like lightning or aurora, the point of origin would shift with the observer's position due to parallax. A viewer in Massachusetts would see it against a different stellar backdrop than a viewer in South Carolina, but they did not. The radiant point was constant. This simple, elegant observation proved that the origin of the display was not terrestrial, not a feature of our own atmosphere, but something far grander, something truly astronomical. These were not falling stars at all. They were extraterrestrial objects, tiny particles from the depths of space colliding with our world. Denison Olmsted, through careful deduction, had effectively doubled the known size of the solar system's population of moving objects. He proposed that Earth had passed through a cloud of particles in space, a revolutionary idea that laid the foundation for modern meteor science. The Great Leonid Storm of 1833, a night of terror for millions, had become the crucible in which a new understanding of our cosmos was forged. The sky was not just a static backdrop, it was a dynamic environment filled with invisible rivers and ancient debris. So what is this river of dust? Where does it come from? To answer that, we must travel hundreds of millions of kilometers from Earth to meet the parent, the progenitor, the ghost that haunts this region of space. Its name is Comet 55P Tempel-Tuttle. It is a traveler on a vast elliptical journey around our sunday. A single orbit for this celestial wanderer takes 33 years. For most of that time, it slumbers in the frigid dark outer reaches its path, carrying it out beyond the orbit of Uranus. There, in the deep freeze of the outer solar system, it is just a lump of rock and ice a few kilometers across, inert and invisible. But as its long orbit brings it back towards the inner solar system, the distant warming gaze of the sun begins to stir it from its slumber. Let us construct an analogy to grasp the essence of this cosmic parent. Imagine a magnificent, colossal ice sculpture the size of a mountain. This sculpture has been infused with primordial dust, carbon, and dark soil, like a snowball packed from the dirtiest, oldest snow at the dawn of winter. For decades, this frozen mountain drifts through an impossibly cold void, then its path brings it closer to a gigantic cosmic bonfire our Sunday. As the sculpture approaches the fire, its surface begins to transform. The ancient ice doesn't melt into water, it sublimates, turning directly into gas. Jets of vapor erupt from its surface, powerful geysers of water, ammonia, and carbon dioxide bursting forth into the vacuum of space. These violent outbursts carry with them the dark primordial dust that was trapped within the ice for billions of years. This process creates a vast, glowing atmosphere around the icy mountain, what we call the comet's coma. And as the comet continues its journey, the relentless pressure of sunlight and the solar wind pushes this cloud of gas and dust away, forming the iconic ethereal tails that can stretch for millions of kilometers. The comet is in essence slowly disintegrating, sacrificing a piece of itself with every fiery passage around the Sunday Comet Tempel-Tuttle is this cosmic ice mountain. And the Leonid meteor shower is the consequence of its perennial sacrifice. The dust and debris ejected during its sun-scorched passages do not simply disperse and vanish. They remain spreading out along the comet's orbital path like a ghostly breadcrumb trail. This trail is not uniform. It is a complex filamentary structure, a river with dense currents and placid eddies. The most recently shed material from the comet's most recent passages remains bunched together in a thick, dense cloud. When the Earth's orbit intersects one of these fresh, concentrated streams, we experience a meteor storm like the legendary one of 1833, or the more recent spectacular displays of 1966 and the turn of the 21st century. These are the years when our planet plows through the thickest part of the cosmic river. For the 2025 encounter, we are not scheduled to cross such a dense filament. We are, instead, passing through the older, more diffuse background stream, the dust shed by Tempel-Tuttle on its journeys centuries, even millennia ago. These older particles have had more time to spread out, creating a broader but much less concentrated current. That is why we anticipate a modest rate of around 15 meteors per hour. It is a gentler crossing a passage through the calmer waters of the stream, but no less profound. Each tiny particle we will see tonight has journeyed for an unimaginable time, a silent witness to the solar system's grand, unceasing evolution. When one of these particles, often no larger than a grain of sand or a small pebble, finally ends its long journey, its demise is breathtaking. It enters Earth's protective atmospheric shield at a staggering velocity. Leonid meteoroids are among the fastest known, slamming into our atmosphere at approximately 71 kilometers per second. That is over 250,000 kilometers per hour. At this incredible speed, the particle itself does not burn up in the conventional sense. Instead, it causes the air in front of it to become fantastically compressed. This extreme compression, a phenomenon known as ram pressure, heats the column of air to thousands of degrees Celsius hotter than the surface of the Sunday. What we see as a shooting star is not the grain of dust itself. It is the incandescent sheath of superheated air and vaporized atoms, a glowing plasma trail marking the particle's final fiery moments. The tiny speck of cometary dust is completely vaporized in a fraction of a second, sacrificing itself to create a transient line of beauty across our sky. The colors we might perceive in these streaks are a form of celestial autopsy. The brilliant hues are spectral signatures of the elements vaporizing. A greenish tint can come from vaporizing magnesium and nickel. The glow of sodium atoms, similar to the orange of a street lamp, is common. Vaporized silicon atoms might produce a reddish hue, while ionized calcium can contribute a hint of violet. Observing these colors is to read the chemical composition of a 4.5 billion-year-old piece of our solar system's primordial material. Sometimes a particularly bright meteor, a fireball, may leave behind a ghostly, glowing trail that lingers for several seconds or even minutes. This is a persistent train, a tube of ionized atmospheric gases slowly cooling and diffusing in the upper atmosphere's gentle winds. It is the meteor's final fading signature, a beautiful scar on the night. So how does one best prepare for this celestial encounter in 2025? The guidance is simple in principle, but requires a commitment to the experience. The universe does not cater to convenience. First, one must understand the enemy light pollution. Our cities, magnificent monuments to human ingenuity, are also sources of a pervasive hazy glare that obscures the cosmos. This sky glow acts as a luminous curtain, hiding all but the brightest stars and planets. To witness the subtle beauty of the Leonids, you must escape this electric haze. Consult a light pollution map. Find a sanctuary of darkness, a state park, a national forest, a rural field far from the city's domain. This journey into darkness is the first step of the pilgrimage. The second requirement is timing. The radiant of the shower, that point in the constellation Leo from which the meteors appear to originate, rises in the northeast after midnight. The hours between midnight and the first hint of dawn are therefore prime viewing time. This is when the constellation of the Lion will be highest in the sky, and your patch of Earth will be facing squarely into the oncoming stream of cosmic dust. The moon, often the brightest and most beautiful spoiler of meteor showers, will be cooperative this year. In mid-November 2025, it will be a waning crescent rising only shortly before the Sunday. Its slender light will not significantly interfere with the darkness, offering us a near-perfect dark canvas for the celestial artistry to unfold. Preparation is more than just logistics. It is a ritual. Gather blankets, sleeping bags, or a comfortable reclining chair. Lying flat on your back is the optimal viewing posture, allowing you to take in the widest possible expanse of the heavens without straining your neck. Dress in layers far more than you think you will need. The November night can be deceptively cold, and a slow, creeping chill is the surest way to cut your observation short. A thermos of a warm beverage, tea, coffee, hot chocolate, is not a luxury but a vital tool for comfort and endurance. It is a small, warm anchor in the vast, cold darkness. Once you have arrived at your chosen dark sky location, the most crucial phase begins: dark adaptation. Turn off all sources of white light: phones, flashlights, car headlights. The human eye is a biological marvel, but it needs time to adjust. It takes at least 20 to 30 minutes for your pupils to fully dilate and for your retinas to build up a chemical called rhodopsin, which dramatically increases your sensitivity to low light levels. During this period, resist the temptation to check your phone. A single brief flash of white light can reset the entire process instantly, undoing 20 minutes of patient waiting. If you need light, use a red flashlight, as red light has a minimal effect on your night vision. This waiting period is not empty time, it is part of the experience. Feel the cool air on your face. Listen to the sounds of the night, the rustle of unseen creatures, the whisper of the wind through dormant trees. As your eyes adapt, the sky will slowly transform before you. First, the brightest stars will appear sharp and clear. Then fainter stars will emerge, populating the voids between them. Soon you will see thousands of stellar points, And if you are in a truly dark location, the grandest spectacle of all will gradually reveal itself, the Milky Way. Our own galaxy will stretch across the sky like a luminous cloud-like river, a band of unfathomable starlight, the combined glow of billions of suns. You are now ready. The stage is set. Find the constellation Leo. Look for a distinctive backward question mark of stars, which represents the lion's head and mane. This is the sickle of Leo. While the meteors will appear to radiate from this region, they can appear anywhere in the sky. Do not stare intently at the radiant itself. Instead, relax your gaze and take in as large a patch of sky as you can. The best streaks are often seen in your peripheral vision, which is more sensitive to motion and faint light. Patience is paramount. There may be long lulls, minutes of seeming inactivity. Do not be discouraged. This is the nature of the cosmic river. Its currents are unpredictable, and then it will happen. A sudden silent streak of light. It might be a fleeting silvery thread gone in an instant, or it could be a brilliant emerald green fireball that paints the landscape in a momentary ghostly light. There is an involuntary gasp, a shared thrill with your companions. You have just witnessed the end of a 4.5 billion year journey. A piece of the solar system's raw building material has just immolated itself for your viewing pleasure 80 kilometers above your head. Each subsequent meteor is a unique event, a personal firework from the cosmos. Over the course of an hour, you will collect these moments, these ephemeral flashes, weaving them into a memory of profound connection to the universe around you. You are participating in a celestial event that connects you not just to the cosmos, but to all of humanity. On this same night, people across your hemisphere will be doing the exact same thing, looking up, waiting, and wondering. A silent global vigil under the same falling sky. As we look to the future, the Leonids hold the promise of even greater spectacles. Comet Tempel-Tuttle is a creature of habit. Its 33-year orbit means that its return to the inner solar system is predictable. It last passed through in 1998, replenishing its debris trail and seeding the storms we witnessed from 1999 to 2002. Its next return is due around 2031, and then again around 2064. These passages will lay down fresh, dense filaments of dust. The Earth will not immediately encounter these new trails, as orbital dynamics require time for the dust to drift into our path. But calculations predict that in the final years of this century, around 2099, our planet might once again plow through a very dense region, potentially triggering another magnificent meteor storm. Imagine our grandchildren or their grandchildren looking up at a sky filled with thousands of falling stars per hour, recreating the awe and terror of 1833, but this time with a deep understanding of the cosmic mechanics at play. The Leonids are a gift that renews itself a celestial inheritance, but on an even longer timescale, the fate of the Leonids is one of eventual decay. With every passage, Comet Tempel-Tuttle loses mass. It is a dying mountain of ice. After thousands more orbits, it may disintegrate completely, or its volatile ices may be so depleted that it becomes a dark, inert asteroid. The river of dust it has created will also, over millions of years, be ground down by the subtle but inexorable forces of the solar system. The pressure of sunlight will push the smallest particles away. Gravitational perturbations from giant planets like Jupiter will scatter the stream. Eventually, the Leonid meteor shower will fade, its parent body gone, its debris trail dispersed into the general background of interplanetary dust. The annual fireworks will cease. The night of mid-November will become just another night. This long, slow decline is a reminder of the impermanence of all things, even on a cosmic scale. The spectacles we enjoy today are themselves transient moments in a much larger story. And so, as you prepare for your vigil under the 2025, Leonids consider the profound philosophical weight of the experience. You are bearing witness to a cycle of cosmic birth, life, and death. The dust was born from the primordial nebula that formed our sun and planets. It was locked away in a cometary deep freeze for eons. Now it is released, and in a final, brilliant flash of self-destruction, it delivers its light to your eyes. The atoms that made up that grain of dust, the carbon, the silicon, the iron, are not destroyed. They are merely recycled, drifting down through the atmosphere to settle invisibly on the surface of our planet. A small, almost immeasurable quantity of comet dust will settle on your hair, your clothes, the ground you lie on. You are in the most literal sense being touched by the ghost of a comet. This act of skywatching is an antidote to the frantic pace of our modern lives. It forces a stillness, a contemplative state. Staring into the depths of space, you are confronted by scales of distance and time that are almost impossible for the human mind to fully comprehend. Your own concerns, your daily struggles, the anxieties of our era can feel small and insignificant against this vast, silent backdrop. But this is not a nihilistic feeling. It is a feeling of perspective. It is the realization that we are part of something immeasurably vast and ancient. Each meteor is a reminder that our world is not an isolated island, but an active participant in a dynamic and interconnected cosmos. We are travelers on a spaceship Earth, constantly moving through a universe filled with wonders, hazards, and the beautiful debris of creation. Tonight, that journey takes us through an invisible river of stars. Find your place in the darkness, turn your face to the heavens and wait. The ghosts of Tempel-Tuttle are coming, and they have a brief, brilliant story to tell.